pretty light crowd today.
believe that
This
this
time.
presenter John here and next one me.
Yeah.
I forgot the name.
Start. So, what time is it?
Yeah, sure. Start.
Silent slide. Okay, let's get started. Welcome to IETF 119 Distributed Mobility Management Working Group. I'm Sri Gandavalli, along with my co-chair.
This is Satoru from SoftBank.
Okay. So, first order of business, please be aware of the IETF IPR policy. Please be familiar with this material. When starting a presentation, you must say if there's IPR associated with your draft, the restrictions listed in section 5 of RFC 3978/4748 apply to your draft. When asking questions and commenting on a draft, you must disclose any IPR you know of relating to the technology under discussion. Please see the references 5378, 3979, and the IETF note will state. So this IETF note well, again, please be aware of all the BCP guidelines. I think we need a note taker. Any volunteer? Oh, thank you so much. Okay, so a quick update on the working group status. Mainly there are two key documents in the working group development process which were recently adopted. One, not the first one, but yeah, one is the mobility aware transport network slicing for 5G. This focus on the interworking between the transport plane and the mobility plane with respect to semantics. Other one is architecture discussion on SRv6 mobile user plane. So I think we have other presentations. So this is what the totally we have. This is what we have on the agenda. We'll start with the working document and go to the individual contributions, individual drafts. So on the individual drafts, we have a MUP architecture discussion from Satoru-san, computing aware traffic steering considerations from MUP, MEP, mobile user plane evolution, mobility capability negotiation, emergency calling. So these are this is what we have on the agenda today. I'll pause here. Any comments or questions?
I think Marco have a presentation.
Marco also has a presentation. Yes, I missed it. Yes. On the N6 steering, Marco will have, we have given one more, but it's my mistake. I should have updated the agenda. There's one more topic here. So with that, John, you want to give an update on where we are on the
Right.
Okay, so this is the mobility aware transport network slicing for 5G. The draft has now been updated in version 08, especially we did significant amount of update to align with T's and going to the updates in this document. So these are the comments we had in the last meeting. So the first comment, I gave a lot of transport technologies. Why are we still doing PPR? And in this revision, we've removed PPR, and pretty much all the transport-related stuff we've removed. And that can be associated via T's and other class. So the second comment was we have the implementation, no interest, no action on So on the other comment was that we need to work with the transport experts, and we are coordinating. The authors are coordinating with TVs. I just did talk to them now about progress. They've made progress on some of the T's framework, I mean, for slicing, but on the 5G draft, they have not made significant progress this time. And this draft is, in a way, linked to that because they have referenced and they are using part of this there, and and we have referenced that work too. So I think there's some kind of a dependency between the two. Keep watching that. So then, how about the control plane slice? And the action is we did add a note on the control plane. Um, so essentially, and I'll get to that in the next, but very quickly, the control plane we're talking about here is SCTP or HTTPS if we're talking about the NFs. The main difference between those control plane and the user plane slices that we're talking about is that the user plane slices are with reference to a service that is offered to the end user, whereas the control plane slice is not something that's offered to the user. So the operator may define and use the slices, but they're not a service that's offered to them. But we've added text, and as we go on, you know, that and any comments will be. The last comment is about is the private network covered, and the answer is that yes, it covers both. There should not be a significant difference if it is private or public. Public networks impose more of an issue in that sense, but we've noted that these techniques of using the source port for identifying the slice applies to both private and public. No specific issue.
So Lorenzo says the mic is turned off.
Is my mic
Speaker
turned off?
mic is turned off.
Is it? Oh, is it turned off?
Yeah, we can hear you.
You cannot.
Mic is, needs to be turned on. Can you check if flip this?
Yeah, it's not.
Can you?
Maybe I'm just doing it. So where's this switch?
Yeah, there's no switch.
There's no switch.
Oh, fuck.
Yeah, there's clearly a difference. Should I repeat what I did or just quickly go through just for the, okay. So just repeating for the folks who are remote or others who have just joined. So this is the draft on slicing for DMM TN-aware mobility slicing. And we had a number of actions that we updated the draft with. And here's a list of those items. So we removed the PPR as a transport technology because we don't want to put that specifically in this draft. Are there any implementations that there's no need of updating the draft? We are working with the transport people in T's. They have a slicing draft that does talk about 5G slicing and some other technologies with VLANs and MPLS and so on. And this is one more technology, I mean, of using the source UDP port. So this draft is referenced over there, and the method is referenced and summarized in the T's draft. And here we have referenced the 5G draft. So any reader that sees both of these, I mean, when they become RFCs, should know, you know, how they're related and how they relate to each other in total. You know. And the control plane slices are covered in you can use the UDP source port to set up control plane slices as well, just like you can with user plane. The difference I was mentioning earlier is that the user plane slice is a service that's offered to the user. while the control plane slices are something that is internal in the network. It's not a service that's offered to the user. So the operator can set up the control plane slices, not as a service to the user, but it can be done and can be identified with using the source port. And the last comment was about that we had to address was, is the private network covered? And the authors think that there's no difference in terms of the usage here with setting up slices for with the UDP source port. And so, yeah, it is covered, no specific issues to address there. So some of these actions do need updates. I mean, basically removing the PPR and some of the updates about control plane and the private network. And in the subsequent pages, I'll show you what has been done. So if we go to the next page, please. Okay, here's a very high level overview, and you can see that the majority of the changes in terms of the chapter headings are that under chapter 4, it's now a lot of the things about applicability and the transport network technology have been completely removed. There's only a small summary in terms of how this work links to transport technology. And then later on, it's just referenced there. So that's the work about PPR. The whole part is removed because it's not needed here. So if there are no questions, we can go to the next. So yeah, here is the text that we've added on to address the control plane and private network slices. So I think there is something, it's a chapter, it's a para in the introduction chapter. But the significant text is that during the session phase setup, the control plane may use other 5G provider slices for messages to carry session signaling or to carry signaling data between 5G network functions. That's the control plane. And the techniques do apply. That's the main point. But it's also clarified that these are requirements that the operator handles. It's not to the user, as I mentioned earlier. The last sentence is addressing the part of the public or private, non-public. So private is referred actually as non-public. So the slice mapping using UDP source port may be used in IP transport networks for public or non-public networks. The next page. So I guess here it's referring to the removal of thing. I don't know how well this represents the removal, but essentially everything that is linked to the PPR transport technology has been removed. What is left is how the transport network underlay may use the source port. There are two considerations that have been left behind. One is the range of source ports that can be used and how security applies to when you use the source ports. So they're a little further down in the text there, but those are the only two aspects that are left, and they're relevant to how the source ports are going to be used for setting up the slice. We'll go to the next page, and I think that covers the changes that we made. And
Satoru Matsushima, Chair Hatov from SoftBank. Can you go back to the slide to see the diff or control plane?
Control plane. I
Thank you. As you mentioned, there's no implementation available for UDP port, source port to find the slice in the transport side. And also, you mentioned that the 3PP specification is not available for UDP source port configuration to send out the packets. So, but this 5G discussion, already have several few years, 5 years or so. So what's the gain to standardize this document to be informational? Because no, no implementation available, no specification available in CPP, how to leverage the UDP source code, the idea to mapping slicing.
Right. I think, yeah, it's true that 3GPP has specified only a few numbers of techniques which does not include the UDP source port, but this solves a specific problem when the attachment circuit comes in the way. So you cannot transfer those layer 2 information across an IP attachment circuit. So if we end up in those kind of server based deployments that have a layer 3 attachment circuit too, where the slice needs to be enforced on the transport network, you need some technology of this sort. And so this is an informational draft that will be of value for any deployment that is going to use something like that. So you couldn't use VLAN or a layer 2 because those signals are not going to carry through the attachment circuit, whereas the source port is going to carry through. And I think that's the value of it.
Okay, now this document provides the UDP source port to be key to mapping slicing.
Right.
And you expect someone ask 3GPP to request some change in the CPP spec to use the source port value in control plane protocol in the 3GPP. So what do you expect that?
Yeah, I think that could be very well the way it goes. I mean, somebody that wants to deploy that would bring that to 3GPP and they would use this as a base, but then extend it to put it in their specifications.
Do you have any idea for the exact name to
in 3GPP?
propose that idea to 3GPP?
It's 28.530. That's where this gets standardized. I mean, it's in the management plane where it is specified.
No, my question is who proposed that request to the 3GPP?
It could be, so I think it could come in two ways. One is you could have a work item, a small work item or a study item that a company proposes. An alternative is to say that we need an extension. So it's just an update or a correction or a feature. Sorry, not a correction.
My
a
question
feature.
is, sorry, my question is, do you have any idea for exact person name?
Oh, no, I don't. No, I don't
Okay.
know. Yeah.
So maybe you expect DMM to send a liaison, hey, CPP, we have an idea to use UDP source port.
I think that would be a good idea to send to the CT and the SA5 working groups to socialize the availability of something like this. Yes.
Okay. So then CPP may reply with, okay, that's a good idea. So what's the substantial implementation to leverage the UDP source port as a slice to key,
Right.
as a key for a slice mapping?
Right.
So, but we have no implementation. So
yeah, that I don't think that should be a problem for 3GPP because when it gets into, they would add to this or then realize their implementations because they go top down in terms of, the specifications and then leads to an implementation. So that should be okay, I think.
okay, so you expect once they find this idea, they implement transport equipment to find the UDP source as a key for the slice mapping, and then they modify the protocol to configure the UDP source. That's what you expect.
That's what I expect.
Thank you.
That's exactly right. Yes.
I just try to follow on the stories thing about the things. Oh, hello. Yeah, okay. Try to follow up with Satoru's question regarding the UDP, the port mapping things. It like, I think for that part, it's like the thing is like either liaison or some work. I think it's in the city 1 or city 3, and then we can bring, well, when they discuss those type of things, well, from their point of view, we can bring this type of the like IETF. By that time, if this one has already become RFC, you can just use this one as a reference to bring there to say, okay, this is something already existing in IETF, and then we can, influence. So basically, by using PCR or CR to influence the CT group, CT1 or CT3, I forget which one, to do the work. So yeah, we can go there to influence. Okay. Other part is just I try to know the slicing requirement for the control plane are defined by a 5G service provider and not specified by 3GPP standard. I try to digest this one, like suppose like a DNN or SNSS AI, those type of things are defined by 3GPP standard, right?
Well,
So-
those are all relating to the contract that you have with the user.
Okay, okay.
know,
So yeah,
For
just-
example, I guess just to expand on that, maybe if there's some confusion. So for example, if you have an interface between, let's say, an AMF and an SMF, and you want to use a slice, that's
Okay.
not, that's
Okay.
something that an operator would do and could leverage this if they are separated in some way.
Okay,
you
got
know,
it. Thank
yeah.
you.
Somebody's in the queue.
Thank you for your presentation. And so I'm a newcomer and maybe cannot follow up your issue in discussing, right? But my interest is the slicing in C-plane. You say, I don't know, the U-plane, slicing in U-plane is something like, what is in English? So streaming like some, but what is the use case of control plane, slicing in control plane?
There is no specific use case per se, because as I said,
Yeah.
the contract is really between the user and the 3GPP network. So that's where
Oh.
these slices are defined, because that's what the service should guarantee. Now, there was a question last time as to whether this could be used for slicing between control plane entities. And to that point, the answer is that, yeah, you can do it, and that's why I've specifically clarified in there that it is not a service that is defined by 3GPP, but this technique can be used to carry a slice that has certain characteristics between two entities that are separated, perhaps deployed in two data centers. So an AMF in one data center and a SMF in another data center may require certain characteristics. I'm not very sure about how useful this is going to be, because this is more of a user plane thing. So if an operator does see value in it, and that's a question, I grant that.
I got it. Thank you.
Any other questions, comments? Sanjan, what are the next steps?
I think the next step would be to sync up with T's. I think the plan that we had was that we could present this in T's to get their feedback. And I've asked them to, bring and present that here if you think it's a good idea, so that way we know what the whole scope of these slicing documents are for 5G. And both groups that have expertise in this can review and comment on that.
How about the LS? Should we do anything, or you want to others want to initiate?
I think at this point it may be early, right? But eventually.
First, let's get the
Yeah.
piece. Okay.
Do you request review for this by yourself or chair?
I worked with one of them is authoring in this draft, and I'm also working with them on reviewing their documents for the 5G part. And so I think at the end we wanted to have a whole, these two documents to look like it should be easy for the reader to look and figure out how to use this. That's it.
Do you have discussion already in the mailing list of the chief?
No, this is offline discussion during the meetings here, not in. But I think maybe we should have the presentation in each of the other groups if possible in that way. Thank you for the comment.
Okay. This is Satoru from SoftBank. I present map architecture update for DMM. So please, next slide. So I briefly summarize the update for map architecture. So now, after a long discussion, the map architecture becomes data plane independent. So now map is a data plane independent architecture. It means not depends on any specific data plane protocol anymore. So that outcome makes our draft file name from change to the MHKK DMM map architecture. That supersedes the previous draft DMM SRBasic map architecture. So that reflects the update correctly. And we are keeping SRBasic data frame in the map architecture document because the SRBasic map is a map architecture implementation with SRBasic data frame in the draft. So to show the exact example illustration with the specific protocol helps a lot for readers how the map architecture works. So that's the reason we keep SRBasic map in the map architecture document. So you can find section 4.1 for data plane consideration and section 7 for illustration. That's almost no change for each section contents. Please go to next slide. So other major update is to introduce architecture principle. So to guide the design and operation based on the map architecture for DMM, we introduced 3 principles. The first principle is segment. The segment defined in map architecture is to abstract the mobile user plane. So we have 2 type of map segment defined in the draft. You can find it in section 4. We have interwork segment and direct segment. So even we call it segment, it doesn't mean very specific data plane protocol because segment is very common and widely adopted for the many technology. Like you can find the segment in Ethernet from many years ago, and segment in multi-segment pseudo-wire RC 5659, which also defines segment in that technology. You also find segment in EBPN, RC 7432, which also defines segment in that technology. And of course, segment routing is the architecture to use segment as a key key component of the architecture. And recently, the network slicing RFC published. In that RFC, they have segment in their definition. So, as same as many other technology, the map architecture defined map segment in this architecture. So this is what the draft defined. So even we say segment, it doesn't mean the segment routing specific thing. We say segment in map architecture specific. Okay, please go ahead to next slide. So second principle is auto discovery for a map segment. To enable map to be a pluggable user plane part of the mobile service architecture, the map P should be able to discover map segment in the remote map P. Otherwise, the user plane be fragmented and never connected to each other. So auto discovery route helps map P to discover the map segment hosted in remote map P. In this document, we have map segment auto discovery route in section 5. The section 5 defined two types of the discovery route. One is interwork segment discovery route, we call ISD route, and the other is direct segment discovery route, we call it DSD route. Those two routes should be data plane dependent. Any data plane specific attribute should be able to attach to that auto discovery route. Specifically, when we see the BGP as a routing protocol, service seat in BGP prefix seat attribute enable to adopt SRv6 as a user data plane. We call it SRv6 map. And also you can find the bunch of the options available from IETF technology from the IANA repository. So please go ahead to next slide. This is what IETF community defined as a data plane protocol code point. So you can find LCTP, you can find GRE, and you can find MPLS, and MPLS in IP tunnel, IP, VXLAN. You can find almost all data plane solution already defined allocate the code point. So if that data plane specific attribute attached to the discovery route, you can use that data plane technology as a map data plane. If you need any other data plane solution, you can request the code point to allocate that your preferred protocol as a data plane. It will be a first come, first out, first served policy to be adapted for IANA repository. That's a very easy task for you. All right, and next slide, please. So last principle was transform session to routing to leverage data plane protocol to optimize the data path for DMM. So we have two types of the session transport route. We call it an ST route in section 6. The type 1 ST route is to for a host route for the mobile terminal and UE or MN. And type 2 is in this document illustrated with for uplink traffic route. The auto discovery route previously I mentioned should be used to resolve reachability for ST routes. And also ST route should also be data plane dependent. Okay. Next slide, please. So this is a reminder why map architecture took that principle. So when we see DMM requirement, we have some requirement to develop DMM solution. So please read the requirement 1, 3, 4, 5 specifically. That requirement is what exactly map architecture principle guide DMM solution and design and operation to fulfill the requirement. Please remind, and please go ahead, go to next slide. So map architecture designed under that principle provide independent from specific mobile service architecture, because the map is consumable by any mobile service architecture, because the session information transformed to routing, and the map segment can be attributed with any mobile service specific user plane behavior on information. The second bullet mentioned the pluggable user plane part of mobile service architecture. The map can be coexist with genuine user plane defined in each mobile service architecture. In 5G case, the genuine protocol is GTPU, but the map architecture, especially SRv6 map, enable the interwork with the GTP and SRv6. The last bullet said independent from specific data plane protocol. That's the main part of the update. The map can be implemented with any data plane protocol using the any specific data plane attribute. So next slide, please. So our next step should be that the course will review the section contents against the architecture principle, because this is the first attempt to introduce the principle. So we will review the contents of the rest of the draft, whether it follows the principle or not. And of course, IETF DMM community review and feedback are highly welcome. And then update the draft to reflect that review result. And then we will request the working group adoption. That's all from my side. Any question?
I have a knowledge. I haven't read it, but
Please state your name. Please state your name.
hello, yeah. I acknowledge I haven't read it, the document yet, but do. Oh, sorry about that. Yeah, I didn't hear that. Oh, Tianji, CMCC. Okay. Acknowledge I haven't read through the document yet, but do you have a picture to show your map architecture? Because I haven't followed through it yet. The other one is what is MSA, the mobile service architecture you referenced here? Yeah, in one slide you referenced quite a few times about MSA. So
mobile service architecture. When you read the draft, you can find the exact name of the mobile service architecture as 5G defined in CGPP, like TS23501, and other is PMIP. I forgot the RFC number, but 3 follow that exact number of the RFC. That's what I mean. Okay. It as a mobile service architecture.
Thank you.
So we come from China Mobile. One question, is there some protocol type for the solution already, or now just the draft?
One of the implementation based on map architecture, the SRv6 data plane implementation is almost available in some of the open source project, BPP and GoBGP. You can find the code in the open source project.
Okay, thank you.
Any other questions? How many people have read this document?
Okay.
Okay, any volunteers who can review this and provide some feedback? Suresh, okay, anyone else? Marco?
Great.
Marco, okay, thank you.
So someone who sees that architecture draft, please be careful. The file name is now different. So please update your draft. Okay.
Okay. Any other questions? That's it. Thank you.
Thank you.
Next one is, which one is the next one?
Hello. I will increase and online. Can you hear me?
Sorry?
Hello, can you hear me?
Okay. Yeah. Go ahead.
Oh, thank you. So hello everyone. So I'm Manili Mibak, and in this presentation today, I want to discuss about computing aware traffic steering consideration for
Okay,
mobile user plan.
one second, one second. Okay, can you little bit slow down? The audio is not coming out very clearly. Just little bit slow down.
Okay. So in this presentation, I will talk about computing aware traffic steering consideration for mobile user plan architecture. We have already brought up this topic in the previous IETF meeting, and after the review and comments from everyone inside meeting room, we have revised the document, and we hope that this time the presentation can clear the confusion of the previous meeting scope and content. Please, next slide. So our graph directly target the mob architecture that had been previously presented in the previous presentation. So the scenario we consider here is handicap address service, which means that when the multiple instance of the same service is represented by a single IP address. So in this case, the mobile network need to choose one of the available service instance to serve the user. And for the current map architecture, it will convert the session information from the upper mobility management system to the data plane routing information. And it might be that the service location decided by the upper session information might not be the optimal one. So for example, it can be normally choose based on the closest geographical distance, and sometimes that closest one might serve too much users. So the question here is how we can support the EDICAT address for the map architecture. And the EDICAT support, we think that it might be inside the scope of the multicast support requirement of the DMM. So how to add the capability to convert the session information to an optimal routing information to an optimal script instead. We want to discuss inside the graph. Next slide, please. So this is a Spoke architecture. So what we do to address the problem is we want to integrate the computing aware traffic steering CAS concept into the MAPC. So the reason why we consider the CAS concept is that inside the CAS framework, the service is represented by a CAS service ID. And any CAS address is one of the implementation method for the CAS service ID. So by integrating CAS into the MAPC, this map architecture can provide support for any CAS. So the basic step is like this. The first thing is the computing matrix and the network matrix are collected from the corresponding matrix engines and reported to the CAS MAPC controller. After that, for each user session, the CAS MAPC path selector, based on the current information, it can select the optimal service internet location. And then after that, the CAS MAPC convert this session information from the upper. The session information need to be extend with the UE location and the EDICAT service address as well. And the MAPC convert this session information to the corresponding routing information toward the service is the location have been chosen in the previous step. One thing to note is that the metric distribution method and the optimal solution algorithm is inside the CAS scope. Inside this document, we only focus about the possible chain to the architecture of the map and maybe possible chain in the routing type, if possible. Next slide, please. So in summary, this pre-presentation we talk about the motivation of the document. That's if we want to add any CAS support for the map architecture. To do so, we want to integrate the CAS capability to the MAPC. The future graph version, we might discuss the possible chain to the possible routing types. Thank you everyone for listening. Please give any comment and suggestion. Thank you.
Any questions, comments, feedback? Okay.
Kenji, CMCC, I try to get one clarification things. This draft is based on the map presented by Satori before. I try to get a clarification question on that one. Satori, just a quick question to you. Is your map architecture that the document based on 5G or just a general architecture?
It is general architecture.
It's general architecture here. Okay, so in this case, to me, it's like I try to understand the new draft here. It's like to put some overlay things and over the MUP your work, and to collect some information from either the service metrics or network metrics and to some centralized, and then so this one is based on the map architecture you have proposed. Yeah. Okay, so author, is my understanding correct?
Just I think it can be the overlay, or it can be an maybe a subcomponent inside MAPC. It can co-work together.
Sorry, I didn't get it. So anyway,
Can you repeat, please?
I think it can be overlay, but it also can be co-work with the map architecture, with the MAPC.
oh, I see. Okay, thank you. Got it.
Satoru Matsushima from SoftBank, chair hat off. Thank you very much for your proposal based on the map. And the idea is, looks to me that clear to leverage map controller to inform the routing information based on the CATs. So you propose any cast address as the CSID. So what format do you expect as any cast? Is that IP address and TID or something?
We suppose it's an IP address. Just a single IP address that can represent multiple instances.
Okay, so if it is IP address, is that the server address or the mobile network entity address or any?
It can be. It's not be a server address. I mean, multiple service instances, they might have their own IP, but in this case, there is one representative IP for all that instance, and you can assume that you can use a DNS to translate the fully qualified domain name to that single IP address, and when the network receives the request to that Anycast address, then it needs to choose a route.
Okay, thank you.
Yuya, you had a question?
Hi, hello. Can you hear me?
Yes.
Okay, thank you for presentation. So I understand. So your problem statement is supporting IP Anycast over the current MVP architecture, but I believe current SRv6 data plane of this MVP architecture is already supporting IP Anycast over the mobile transport layer by using Anycast seed. So I didn't understand what is the problem to support Anycast, but I believe so. This proposal is just doing IP Anycast support along with current CAT framework. Is it correct?
Yeah, I think what we want to add is add the capability to collect the matrix and then decide the optimal instance based on the collected matrix to the MAPC. I don't think the underlay SRv6 need to change anything to support.
Okay, so you mean the IP Anycast is sometimes done by based on the network layer metrics like ISIS metric or BGP metrics. But so in the CAT framework, so they are using another metrics to choose appropriate make site. So in that, so you are now going to propose so using another metrics to select the make site following the CAT framework. Is it correct?
I think any metrics could be possible to select. We do not focus on the specific metric here. It's just a way to choose a service instance for an Endicast service. Then we need something some kind of component to choose the instance. So it's a lacking now inside the mock controller if we want to support the Endicast.
Okay, thank you.
Okay, quick question. Yeah, quick. Just okay, fine, go ahead.
Yeah, I just try to attend G76 again regarding your CAT integration part. For the CAT, I'm not sure the CAT has already specified use the centralized controller to distribute the CAT metrics. Can you confirm that one?
Inside the CAT right now, there are still two implementation way. One is distributed and one is centralized.
Okay, thank you.
All right, I think we need more reviews on this document. Folks, please post your reviews, mailer, please. Okay, thank you. Next one. Okay, discussions on integrating AN and UPF.
Okay. Good afternoon, everyone here. Tianji from on behalf of the authors to give a presentation about this one. This is already the version 8 of the things. Okay, go to the next one. Yeah. So oh no, no. I think there's one more slide. Yeah. Okay. So this is the work that has been running through different or quite a few IETF meetings. It starts from the 114, 16, 15, 16 until the 17 part. Until that day, the 17, 117 has been on the technical discussions from different angles, areas. Well, here the first part that recaptures of the technical things. And then by 17, after that, we believe the authors think it's already mature already for one adoption call. So we asked the chair to start the adoption call, and then we did get some comments. Yeah, one way or the other. And then for this presentation, I'm here to address those comments from the adoption course. But the thing is here, I want to give one update is after the 118 adoption call, and then in November, there was some discussions in the 3GPP part for the 6G roadmap. And I have in the draft they're saying, okay, the work is targeting for the future for the 6G. That's why I put there's one reference document. It's talking about the distributed and autonomous CN core networks. So it's it depend on some use cases, and then this one is getting more attractive toward the 6G things. And then we believe that one is does support our argument or our point here to integrate the Genome B or whatever we call it, the base station and the UPF functions together. So that's why I put here. This is after the 118 work. Okay, the next one. So we have received three major comments from adoption call. The first one is about the user plan and the control plan discussions revolving around the ANOOP things. And then, so basically from the summary about the chair's review is seems one is inconsistent on the C plan discussion compared to what author has argued. Uh, Here, our argument here, well, we basically agreed is the comments on the CP that the control plan does play a pivotal role in realizing the original DMM principles, but the genuine potential of ANOOP can be fully excavated upon the consideration of both CP and UP. Yes, it is, but still the thing is, our draft is it's centering around the ANOOP or MUP itself. So it's a potential advantage with with integration of the GNOB and the UPF. So our work will revolve around the ANOOP. It's not going to talk about the broader sense aspect of the 5G or the later 6G control plane. Well, I give some examples like RM, registration management, mobile management, session management, paging, all kind of three GPP centric things. So this is for the answer to the comments here. Our work is centering around the CPUP for ANOOP, but not on the broader sense of the 5G or of the later 6G CP control plane. Next one. For the second, oops. Okay, for the second comments, it's about because there are quite a few comments regarding about the very strict GPP centric, like SMF N4 session, and the AMF N2 interface, all kind of things. So here is like so it's more strict GPP centric things, more questions. And then when this is just is like the issues and our replies, and also chair's review, all kind of things. And then can you go to the next page? But just to give the answers to this comments is like here, as set forth at the beginning of the draft, the 3GPP work will at the 5G 6G work will be done in 3GPP, not here in the IETF. And then what we have acknowledged things like although we do list something it's critical and related to this draft, and then but those things have to be done in the 3GPP Standard Development Organization or SDO. And also we acknowledge the 5GS or later 6G for sure will be complicated. And then, we believe our ANOOP have certain advantages, impacts to the current 5G, the CP. But those things, if that things is good, and then, we hope this one can be explored along the time once the draft is adopted. To summary, we have no intention to merge, the specific question like merge N1, the NAS, the N2, the NGAP interface, and N4, the session part. We're not going to do those same things. We're going to do the work for the IETF, and we're not going to cross into the 3GPP. But still here, in order to address the concerns from the DMM mailing alias, and we have made some changes in this version, like to remove more 3GPP control plane centric sections, like ORM, mobile handover, paging. Those is also really complicated, but it's not centering around the ANOOP we are discussing. And also we revise some sections like the satellite part move to the section 4 and merge with some bullets there. Here, I emphasize the section 4 is regarding its current release 19 seed work from the 3GPP to propose to handle some satellite-based case. And then for the solutions that have been proposed by different companies that have not yet been concluded in the 3GPP SA2 working group, but still, cause for that particular case, cause the scenarios is kind of a challenge. So companies, some some solutions have proposed to merge the registration and the session establishment part. So this one, in our opinion, will bode well for the future, like potential integration of the Genobi and UPF, but it's still being concluded in 3GPP side. And then also we remove some and revise to just try to make the thing is easier to follow through. Okay, well, later I'm going to show the XDiff about, okay, what has been done. Okay, the next, Number 3 is regarding, okay, when it comes to the consensus should be provided by the running code. Can you go to the next one? It's like here, well, I use this picture I borrowed from the 3GPP to show the different stages, how 3GPP works. Basically, for the 3GPP workflow, it's comprised of 3 stages. The first one is like the use cases and the CPR, it consolidated the potential requirements. And then go to stage 2 and the standardization, study, and the normative part. And then the stage 3 is the protocol and the coding part. So what we have proposed in the draft is revolving around sharing of some high-level architecture evolution. So in our opinion, and then this is more between the stage 1 and the stage 2 work. It's not on the realization, protocol implementation, or coding realization. That is stage 3. So so there's no running code, but it's a more high-level architecture evolution. So this answer for the number 3. Can you go to the next one? So in summary, things like, okay, so we believe we have received, we do have received the positive comments from some participants from the mailing alias. And then, but we still have to things, okay, well, we acknowledge the actual spec will need to be happening in 3GPP, but we have raised some very good point, something that can be later for the reference for the next, for the 6G roadmap or for the future reference. And then here some suggestion from comments, also from the ADS. Okay, something can be done if this one is adopted, or just leave 2 bullets here. So then next. Next, just to give you what what are the differences between the number 6 that has been adoption call for 118 and 08 is this one. So this is just like to give more. It's easier to follow through, and also we removed some more 3GPP centric things. Only leave the control plane and the user plane works centering around the ANOOP things itself. So in conclusion, this one, the revision 8, is more ready now with the new changes, and also the imminent approaching of the 6G. The 6G work will start next year. And remember, I mentioned is the SA1 work about release 20 about the distributed and autonomous CN data seed is still is being discussed. So for these things, can we try again about adoption? So this is the thing. Thank you.
Any questions, comments? John?
Yeah, this is John Kaipalamalan. I read this draft very quickly, and I can see the changes from before, which were more 3GPP centric. So I think that's great. There's a lot of information in here. I mean, about all the various different modes and things like that, which constitute a good reading and also gives you good perspective. But it would be good if it's possible to add something about how to use this draft. So it starts off straight away with current user plane, but prior to that, if you could say, what a reader could do with it. Is it a survey, or are you proposing that there are some gaps that, I mean, I'm for the adoption and all that. I'm just saying that there may be something that will enhance this further in terms of value, for the readers.
Okay, thank you. This one is we're targeting for the informational. Here, the things like the 3GPP side are discussing about how the 6G is going to architecture, how it's going. So there's still a lot of debate and discussion there. But we do believe here. Well, here I reference one. New SA document toward the 6G, they are more distributed and autonomous even for the core network. So this one is a similar thing. So when you have a distributed core network, so the better from the data plan part is we should have something there for the future reference. So yeah, that is about these things. Yeah. Okay. Thank you.
I think one thing that is important is TNG, like in the mailer, whoever provided the feedback, if you can post the text and get their feedback, whether if they agree with the resolution. I think that will be good.
Sure. Yeah, sure. I can put this one on the alias and to collect all the feedback. Yes.
Yeah, you need to close it with each of the threads because there have been quite a few comments during the adoption call.
I think I got this one from the chair slide, and then about to summarize here the number 1, 2, 3. So basically to give all the major. Yeah. Other part is positive. This is like a concern. That's why I answer all the 3. Yeah.
All right. Thank you.
Oh.
Yeah. Please go ahead.
Hi, my name is Mohammed and I'm from QUT. I didn't have chance to read this draft, but I had just a couple of quick questions. So firstly, about this idea of integrating access network and UPF, have you discussed, is it discussed by 3GPP as well, or is it your only at IETF?
No, it's not discussed in 3GPP at all. Just this is the future work. We try to give something later. Remember, we believe there are some work for the 6G that might benefit from what we are going to propose. Like one example, I give like the satellite store and the satellite case. And then for that unique scenario or use case, some companies have already proposed solution to put the registration part and PDU session set up together. So it's like for some more use case or scenarios, it's going to have like an integration on some parts. The other thing is the distributed and autonomous network for that thing proposed for the 6G things. And then it's going to, the trend is to integrate something. So here is discussed in IETF, but it's referenced later for the 3GPP. Yeah.
Okay, and just one thing more. So when we talk about G Node B or access network, we have a protocol stack for these. And then when we talk about UPF, you have protocol stack there as well. So what would be the impact of integrating these on the protocol stack?
Okay.
Standard 3GPP protocol
Yes,
stack.
a good question here. If you try to think about we're not going to impact toward the air interface side. We're only about the integration part will be on the N3. Well, if we call the 5G things from the G Node B to UPF things, the protocol stack already now is the GTP tunnel things. So we can discuss that things. When you put them together, the GDP may not need it, but this is still we can discuss more about that things because if the still there, it's just like an integrated stack. You received like uplink and the Genobi get it, and then it do some from the DRB mapping and then to by using the 5GS it got a QS flow and then to map and put into the GDP tunnel that is current things. But when you integrate them together, the whole things can be, is maybe it's like simplified, all kind of things. So this is all more on the protocol stack, how it's going to implement it. So yeah.
Let's take it offline.
Okay, sure.
Can I ask one more?
Okay.
Just one
Sure.
comment. So if we assume that we have a slice network, I mean, and because UPFs are different for different slices, so I'm just thinking like how this architecture would be relevant to that scenario. Like if we have a slice network at core.
Oh, okay, well, a good question is for slice part, you're just like some context. So the things like you can spec, that is on the implementation part. You can just specify, using, I'm not sure how it's being done on the transport for slicing, but those things will not go away. You still can use it. Yeah.
Okay, thank you.
Yeah, sure.
Thank you. Next, yeah.
Yeah, the next one.
Oh, one more quick. Yuya.
Yuya?
There was a question.
Hi, hello. So I'm a person who made comment number 2, and I a little bit disappointed that the section about the paging and handler was removed the latest document. But I understand what is the motivation to make this draft to working group draft. But so we need to clarify we adapt this draft as a working group draft, and why we need to input this working group document to 3GPP. And that is
Okay.
yeah.
It's like yeah, sure, no problem. Like a suggestion, I can put this one after the meeting. I can put on the alias, and then I'm going to collect all the feedback and then to answer it.
Yes, please. So because we can make some suggestion to 3GPP as a delegate of the 3GPP. So in spite of that, so we are now going to bring this document to 3GPP as the input into the SAO stage 1 and between stage 1 and stage 2. So we make agreement about what is the purpose to bring this document to 3GPP. That is my comment. Thank you.
Thank you.
Okay, thank you. I think we can stop here. Yeah, next one.
Yeah, this is there's another one. So it's like mobility capability negotiation. It's called MCN. This is a new revision. Yeah. The thing is like I try to give a history because the version for the 10 and then 11 have been presented. One is in Yokohama for 116, and the other part is for San Francisco 117. And then from the 116 to 117, we have made a significant restructure and the changes for this draft based on the feedback comments and to put more discussions around the 5G things. So if you can look at this XDiff between the version 10 and the version 11, so you can say, okay, one for the version 10 is more toward the IPv6 mobile IPv6 part, and also a little bit about the 5G, but it's on the mobility pattern. But for the version 11, and we have give a significant restructuring and then propose based on more analysis, propose a dichotomy of a mobile mobility management and the capability negotiation. I'm going to reference MCN. So for, oh no, not yet. Not yet. Yeah. So for the MCN things, and then we talk about MCN in the mobile IPv6 domain, and also we extend this part. This section was added in the version 11 about MCN in the 3GP 5GS, including two scenarios. One is the general scenarios, the other is the roaming scenarios. Yeah. Can you go to the next one? So this still the history walkthrough, just try to get everyone on the same picture. And then for the version 11, and then so we basically to analyze the mobility capabilities for two domains. One is the wireline domain, so like mobile IP devices. Other is for the wireless domain for mainly for the 5GS devices. For the wireline is focusing on the IP related address allocation provisioning. traffic steering, redirection, and optimization, etc., etc. But for wireless part, in addition to the mobile IP related capability I just described, and also it's going to have some very specific categories like the radio, like a mobile like MMCN, like a session management of those type of things is also belong to the MCN we are discussing here. So based on the analysis of these two, the mobile IP and the scenarios, so we summarize the current protocols for the MCN into two. Yeah, can you go to the next? Two types of protocols. One we call the host initiated. The other one is the network based. So the host initiated, where we just basically the host will have active involvement of mobile end devices in order to accomplish the MCN. Well, for the network based, the network is going to be the centric. It's going to be the going to play the pivotal roles. And well, the end of the host will require non minimal involvement from host. So we give these two types of protocol. One host initiated, the other one is the network based. You can go to next. So next. By using these two types of protocol we have proposed, and then for the mobile IPv6, and then we put the current mobile IPv6 protocols into these two buckets. And then, here about in the draft, it has listed all kind of, we reference all kind of RFCs, the existing protocols like MIP v6 or MIP v6 suite protocols. The other one is the network based. So the network is going to play pivotal roles for a proxy MIP v6 and MIP v6 suite protocols. The draft itself has all the details. You can go to the. And then we discuss this MCN in the 3GPP 5GS general scenarios. Because in the previous slide I mentioned, the 5GS is is very complicated. So there's no clear cut. It's only like host initiated or network based. So the thing is like here, as the first line, we mentioned here, we're going to discuss both the very specific MCN and IP based. So for the very specific MCN for the 5GS general, it is like the integration of both host initiated and network based. I gave one explanation or a line explanation about like a UE initiates process by providing its capability to the network, and the network negotiated based on system settings. So it's like the integration of host initiated and network-based modes. And for the 5G, the UE IP address negotiation and management is also comprised of both the network-based, like a dynamic mode, or host initiated, like a static mode. It's a very flexible and versatile provided by 5GS for these things. So 5GS is very powerful, or it can cause flexible, or it's complicated in other words. So here it's both from side. And then for that is the previous slide talking about 5GS in the general scenario. Well, this one is talking about the roaming. One is the home routed roaming. Is all the details in the draft, and also toward the right hand side, the pictures. So for the home routed, it also has the integration of both the network-based mode and host initiated. So the is like but for the other thing like a local breakout, but local breakout, because of the mechanism of the 5GS spec, is there no host initiated? It's more on the network itself going to be the centric things. Well, also we give one analogy example, like the edge is the home UPF. So home UPF is the UPF when we talk about the roaming case, when the UE is in the visit network. So the home thing is on your home network. So home UPF, just like the home agent in mobile IP domain. Well, in the local breakout is like a VUPF. The VUPF, the visited UPF, is like a mobile access gateway. So we give also the details are in the draft. Yeah, can you go to next? Since then, that is still from the San Francisco. Since then, we have made some changes, not too significant, but most of the changes are on the subject line to make the draft easier to follow through and more structured. And then yeah, this is the XDiff between the draft 11 and the 13. This is a change since the last San Francisco talk. Yeah. So the summary here is like, we have made the significant change and the structure and the proposed based on analysis of the mobile IP and the wireless things, and then propose a dichotomy of the MCN protocols. One is host initiated, the other is the network based. And then we discuss about from the wireline side and from the 3GP 5GS. We believe what we have described can be extended along the later. Well, we do not know what the 6G will be like, but we try to be more general. So when we look at what the DMM working group have done, we can see the DMM working group so far the adopt is more around the user plane, while this one is toward the management plane. So yeah, so we try to complement what the DMM seems lacking of by proposing this one, and hope the working group will consider this as a adoption candidate. Thank you.
Okay, thank you. I think the issue is we don't have MIP client stack implementations anywhere. So
Client stack.
yeah, mobile IP client stack. Mobile IP client stack. We don't have any implementations.
Oh, so you. Okay, sorry, I didn't get that question. It's like something.
Okay, we'll take it offline.
Yeah,
We'll
yeah,
take it
sorry,
offline.
I didn't
Okay.
get that.
All right. I think yeah, we'll discuss this on the mailer. I think,
Sure, no problem. Yeah, I will follow through.
I
Yeah,
think,
after this.
we need to understand why it's required. Okay, thank you.
Sure, thank you.
Okay, thank you. So this is not exactly specific to mobility, but wanted to get some feedback on what we can do here. So what we are trying to do in here is like if you have a cellular device, you can make an emergency 911 call or 112 call by attaching to from the operator network. Now if the device is let's say if the device is not in the in the vicinity of any cellular network, right? Or if it's a Wi-Fi only capable device, right? So what's our answer for the emergency calling? Can the endpoint using a native dialer without any credentials, let's say I bring in my device, I need to make an emergency call, but here there's some Wi-Fi network. Without any access credentials, will I be able to latch onto that network, discover the network, latch onto the network, obtain the voice configuration, and be able to make the call? I think that's the use case we have. I think we proposed, solution based on a federate, the roaming architecture based on open roaming, or it's largely applicable to any roaming architectures, but in FCC CISRIC, adopted this solution. So now FCC is reviewing the technical work and they're trying to do a rule making. I think we'll go over that. So next slide, please. So again, the scenario description, the use case is like, the device has Wi-Fi capable device. There may or may not be SIM capable, right? But the Wi-Fi is available. It's in the proximity of some Wi-Fi network, right? And just for this discussion, let's assume that the cellular network is not available. Maybe I'm in a basement, or maybe the device is Wi-Fi only device, right? In all of this, like, the user dials a native dialer, calls a 911, user dials 911 using a native dialer, device discovers and attaches to the open roaming hotspot. I think, don't be, be stuck on this open roaming thing. It's applicable to any architectures, any federation architectures. It shouldn't be, any identity separation architectures. It shouldn't be specific to open roaming, but it's just an example. Now, temporary access is granted for the device for making an emergency call. So device obtains the voice service configuration. User call is routed to the emergency voice network. The call is routed to the nearest PSAP. I think so. This is what we want in it. I think, so what are the elements in this? Next slide, please. So from the technical point of view, these are the key requirements, right? From network identification, how do I discover a access network which allows emergency calling, meaning without having any direct relationship with that access network, will I be able to say that, hey, give me access because I need to make an emergency call? So that is one aspect. I think for this, the answer that we are looking at is pass point profiles. I think the recommendations that we made to FCC is like, every device that comes out of the manufacturing, an Apple device or a Samsung device, it comes with emergency pass point profile. So pass point profile is widely supported in the device ecosystem. So this pass point profile, it will have a special RCOI, roaming consortium ID, that is exclusively for emergency support. So my device will have all local specific pass point profiles. If it's a North American device, I'll have a pass point profile specific to that. If it's a EU device, it will have a pass point profile for the EU. Now, when I'm making this call, if there's no cellular network, automatically it will activate this profile, discover the network that supports the pass point profile. Meaning if the access network here, let's say IETF network, it supports emergency services. The RCOI, the roaming consortium ID, it will match the pass point profile that I have in the device. That way, I'll be able to get access. Now, on the access network, I'll not be able to permit it to do anything else. I can't browse a YouTube, or I can't go to CNN.com. It's only for one specific purpose, which is emergency call. So now I think why we are bringing like an open roaming kind of architecture. I think the thing is, we want the access networks to be like, have some level of immunity. For example, if a call fails, right? Then why as an access network provider, why am I providing this service? I think that's where the recommendation again to FCC is like, FCC, like, every user, if I look at my telephone bill, every month I'm paying something on the 911 services. So we are making a recommendation that broaden that out, allow Wi-Fi devices to connect to that emergency, make emergency call. So now as part of that, I think we want FCC to give immunity to the access network, meaning if a call fails, right, the access network is not liable. The liability is shifted to the FCC. So that is another aspect. Now, emergency, it's service configuration. Like I think the question is also, okay, I'm making a user native dialer, but where is this call terminating? I think again, this like essentially, today's every operator have their own IMS network. My call goes to the IMS network if I make an emergency call. Here again, the rule making is FCC. What it's considering is like, can they fund a standalone emergency voice provider for supporting this service, or use the AT&Ts and Verizons or any other operator in the world, right, to support based on the regulatory domain, be able to like extend the IMS network to be used by Wi-Fi devices. So another important aspect is if you look at the signaling, the access network location. See, I think location is central to all of this emergency calling. If there's no way to really provide a mechanics for like, detecting call location spoofing or other things, the system will collapse. So the framework that we have is like essentially we want to be able to, by bringing in open roaming kind of construct, the access network and the identity provider, in this case, let's say FCC designated identity provider, the access network will signal the access location. Let's say I'm in the IETF network. The access point here says that, this device, is using the pass point profile connected to the network. The location I can with certainty provide that this is in this area, in this specific location. These are the civic or geo location, and can be signaled to the IDP. Subsequently, when I make a voice call, in the SIP headers, in the SIP PNE headers, I'll include the location which is already supported. Now, the location that the endpoint is signaling can be correlated with what the access network is saying. Meaning, as part of the radius exchange, when I use a pass point profile, when I attach, the access network is signaling my location to the IDP. So so there's a dip, location dip that happens that will allow, to allow the voice system to know that, can do a cross check whether the location that's being signaled is it correct or not. So yeah, that's the rogue caller and other aspects. Next slide, please. So if you look at the overall system here, there's a access network, and there is a identity provider. There's a CLF function, which is a location client location function, which is, now I make a call, I as a user, that endpoint using the RCO, emergency RCO, discourse access network gets access, right? As part of that, the access network signals the location. See, this location can be a civic location, geospatial coordinates, or it can be a device specific location, meaning if today in Wi-Fi networks, we do support indoor localization. At a 1 meter level accuracy, we are able to identify the location of the user. Now, I can essentially, construct a location tag like hashtag XYZ and the real indoor location, and the access network can signal these two elements to the identity provider. Now, essentially, if the location tag is provided to the endpoint, this is where we need a little extension to SIP PIN header. The SLT will be included in the PIN header. That way, when the voice call goes to the PCSCF, it will, using the SLT tag, it will do a location dip. And then what comes out of the location dip is a precise location of that particular user. So this is, so there's another aspect to that. But overall, if you look at this system, I think, again, why IETF, right? I think IETF has done all the IMS work, like, SIP work, right? There's a aspect of, like, overall the DHCP stuff, how we obtain the SIP configuration. There are quite a few protocols in place that, that are relevant here. So what, I'm asking IETF is essentially, can we, publish a specification, right? Like, essentially, this also, this can save a life. I think there's no agenda here, corporate agenda here. This can truly, save a life if you support this. So any questions? Any last slide? Yeah, this is bits and bytes, but yeah. Marco?
Marco Liebchen, see. Yeah, just a general comment. So I think the use of non-3GPP access gets more traction. And I think it's important to support these kind of services through non-3GPP access, in this case, Wi-Fi. I was just not so clear how much the solution you have in mind with this architecture that you draw depends on the 3GPP backend or a cellular backend, right? So I didn't see the typical cellular core functions, but it obviously depends on a AAA backend. It depends on maybe a shared or common kind of SIP-based systems for the telephony, right?
Yeah, I think that's a good question. Actually, in the FCC SysRig also, this question came up. If you please go back to the architecture diagram or where we show the CS. Yeah, here I think I purposely, Marco, next the architecture diagram. Yeah, this one, right? I've explicitly used the PCSCF, but if you look at PCSCF, it's nothing but a SIP3261 SIP proxy, right? This can be deployed using IETF protocols and services. But I think, it's easier. I think, just to really, I think the best thing for FCC to realize this is go to an operator who already have experience in this because they have all the integration with everything, right? If they can, FCC can pay them and extend this to be used for Wi-Fi access. I think that way we can, we don't have to bring in some new IETF functions, but already off-the-shelf products which support IMS, voice can be used here. So, but I can redraw this diagram using like SIP proxies and generalize it. But it's easier. I thought it's easier to just leverage what is already deployed.
Sure. Yeah, thanks for the clarification. So in general, a useful direction.
Thanks, Mark.
Kenji, CMCC. So for the non-3GPP access here, like using the Wi-Fi part, I know there's a lot of discussion. First question, there's one very critical requirement is for the authentication and authorization. And then I think the 3GPP has put a lot of effort on there. in order to authorize, authenticate a user through the network. But here is like so since your arguments are since they're emergent, so it doesn't matter, just get it through. No need to go for like authentication, authorization, those things, right?
Not really. Today, I can make an emergency call with an expired SIM, a SIM that is removed from the handset. The operators do support that. So it's not required that. I think, but in fact, I think the question of authentication comes up because, can we expose the identity? I think, see, first thing we need to understand is there's no specific credentials because we want this to be widely, when off-the-shelf device, when it comes from Apple's in manufacturing or whatever, right, we should be able to use it, right? So this is where the Apples and Samsung these days are also, they're supporting their own default device identity, default device credentials, right? I think one possibility is use those device credentials. That way there's some level of us, a proof, like, to the backend system that at least this call is coming from this particular device, right? But to your point, yeah, even 3GPP network, there's no authentic. I can make a call with an expired SIM and with no SIM.
Okay.
I can detach a SIM card and I can make an emergency call.
Okay. The second part is like for the non-3GPP access here, and then you try to make a call, those type of things. And there's also never to put on like IPsec between the your gateway, like a Wi-Fi gateway to the other side. So are you also considering that part? I try to see where are you going to put those like IPsec tunnels in order to protect your privacy.
I think 3GPP has solutions for if the device is cellular capable or SIM capable, right? If it can reach the operator's network, their existing solutions, whatever they have, even though nobody in the world has deployed a emergency EPDG, but at least whatever 3GPP has done, so be it. I think we are not touching that. I think my entire focus is this is a Wi-Fi only device. It's a laptop Wi-Fi only device. I should be able to make a call. I'm in a basement. I'm in a basement. I can't see a cellular signal. That's it.
Okay, no.
That's my use case.
Yeah, I think I tried to ask the question and for non-3GPP access. In your case, it's a non-3GPP. It's like you have the Wi-Fi gateway, and then it has to get some like IPsec tunnel, something like that, in order to protect your privacy. And then the IPsec tunnel has to be from your Wi-Fi access gateway to the other side. So what is your other side? Yeah.
Yeah, I think the radius. I think two things from the access point signaling to AAA. The standard AAA security mechanisms are in place, right? I think Radix and other what they have specified. I think it's secured there. I think nothing that we are revealing on the wire. Those protocols, they're already in Radix group has done enough work there, so we don't need any new extensions, right? With respect to SIP call, it's a standard SIP call 3261 based, right? Only thing is we may need a few bits and bytes, but overall it's the same thing. Nothing specific. We are not requiring a whole lot of pieces here. Actually, I think what we are doing is gluing all the pieces and making this work actually. And I think there's expertise here. If IETF reviews it and says that, yeah, we believe this works, right? I think that will be a great validation.
Okay. Yeah, the last question regarding you said there's no need to IMS, but the thing is like, so when you from the left side, from UE calling into your data box, if you do not have the IMS here and on the way back, how it's going to route back to the UE? So the UE has some number, right? Phone number for the routing.
See, if you look at the IMS system is again based on SIP system, right? I think, just gave a 3GPP color, few extensions, but largely the SIP-based protocol and infrastructure, right? So nothing, it's the same mechanisms actually. I don't know if that's your question, but yeah.
No, the things like so from your UE, so it's going when you the call and they're going to offer its own phone number to the system. So on the way back from like the other side, it has to route to your phone number, right? Someplace, somewhere through the
As part of the SIP registration, like what happens? The device first gets an access. It discovers IMS configuration and makes a SIP registration. As part of that, now the endpoint is reachable via a SIP, as a SIP endpoint, right? The proxies, can reach the device. Now the user will be able to make 911 call. That call goes to the ECSCF and it does the call routing to the nearest PSAP.
Okay.
So we can talk.
Yeah, I'm going to read the more detail about your things. Thank you.
Any other questions, comments?
Thank you, Sri. For the new pieces that are required here, is it just some SIP location header information? Is that the
Yeah,
only
that
thing?
is one element. Yeah, exactly.
Okay.
Just we don't need a whole lot. Eric.
And I may have missed it. Did you already ask SIP core?
Not SIP core, but I was in touch with Murray and he suggested I go to ECRIT, but that group is no response from the chairs. It's literally dead. That's a dead group.
Yeah. Let's email the SIP core chairs.
Okay.
And ask them their advice.
Okay.
That might be a place to start.
Okay, sure.
Yeah,
Thanks,
thank
Eric. That really appreciate it. Thank you so much. Last. Oh.
Hello.
Yeah, please.
I have a question here. When you are assuming that there is already a Wi-Fi connection happening between the base station and the access point and the mobile, do you want to extend to have a sort of emergency connection to SSIDs or something like this? If you are in a basement and you don't have a pre-established Wi-Fi connection to the access point?
No. If I'm in a basement, if I don't have, I think there are two cases. It's a Wi-Fi only device is one case. Obviously, there's a cellular network is not even relevant, right? The other case is it is cellular capable and Wi-Fi capable, but the cellular network because it's in a basement, you're not able to see the signal. In either of the cases, right? I think the assumption is without having any access credentials to the Wi-Fi network, can the device attach to the network, get access so that you can make a call? That's the scenario.
Okay, and clarification question in the communication with the AAA building block, you are mentioning radius. Last time I looked at IMS specification, people were using diameter. Is diameter intended and radius is a fallback, or radius is the main protocol to be used here?
Yeah, I think that's a good question. If you look at most of the enterprises, diameter is not deployed, right? In Wi-Fi networks today, it's mostly radius. So that's why it's good to keep it to limited to radius. Yeah.
Okay, thank you.
Thank you.
One more.
Darren.
Darren Dukes. What happens with bad actors who want to make sure that you don't get to call 911, or they think that you're somewhere else that you're not really, if they can mess around with the Wi-Fi endpoints and move them where they like them?
Yeah, I think, so Darren, that's a good question, right? So let's say an endpoint, a spoofed endpoint, it tries to signal some location. Let's say I'm here in Australia and it's maybe this, maybe the call goes as somewhere from Adelaide or something, right? The device is claiming that the location is some Starbucks in Adelaide, right? Now, if the system we have in place, when the SIP call terminates to PSCF, essentially it does a location dip with the CLF. So with the identity provider. So that CLF would have obtained the location from the access network itself, meaning the Starbucks access point, where it's supporting this emergency access, also signals my location to the CLF. So there is a location entry that's in the CLF. Now the IMS network makes a query, am I seeing this device, right? This whatever, right? Is this a current location? So that way we can immediately, the IMS network can know that, okay, this location is not what the endpoint is reporting. Endpoint is reporting that location is not matching what the access network is saying. So that way you can detect any rogue callers.
Okay, but it would be the access network that is the thing that is manipulated, right? Not the endpoint. And the endpoint may not even know where it is. If it's in a basement, has no GPS, it knows it's in a basement.
Okay, so your question is if the access network is spoofed. I think, so here, if you look at the open roaming kind of thing, there is a legal agreement between the access network providers and identity providers. So they're operating under some framework, I think that's another thing. Actually, the most important aspect is the immunity that I talked about. We are extending the same legal framework. So it's not some rogue network. It's not any network. It's a responsible network with some agreement with the identity provider.
So the network then assumes some amount of legal responsibility for providing this service, which like a carrier network would be doing, but it's doing it for free maybe. So okay, it's interesting, and it'll be interesting to see what the feedback is from people who might want to deploy this,
Yeah.
and if it would be in like home routers and unmanaged devices and that sort of thing. Thanks, it's real interesting.
Yeah, thanks, John. Yeah. Okay. Marco. Marco. Yeah.
This is the trial permits section. I will not eat up the rest of the time.
We have 15 minutes.
But
It's the last presentation.
so mobile traffic steering, we didn't ask for a presentation slot this time because we did not post a draft yet, but it's on its way. Nevertheless, people asked about the status, so here we are. Briefly about the topic background. So we addressed or readdressed the mobile traffic steering aspect. That was an original kind of challenge for DMM when it has been started. We brought this up at IETF 116 and also referred to applicable solution drafts from past DMM work. So the problem was there, some solutions were there. So we brought it up again and had a lot of time for discussion, also between 116 and 117 IETF. We organized a public site meeting at San Francisco IETF and having a good amount of people there. And we discussed, well, use cases that go beyond the actual base scenario that we briefly show. Also, we received fair comments from people about applicability and limitations. That was really good input. We created a list of challenges to look at, and we converge on a value and scope of a document which we are currently writing on. So draft is being compiled. Next slide. Very quickly about the basic scenario where this started with, also in the context of original DMM scope. So if we have a mobile communication system today, control plane and the data plane, a user plane, anchor or function in 3GPP. So there are scenarios that are more dynamic and agile. So the mobile communication system may relocate the mobility anchor mid-session. So how to treat the rest of the path from the user plane function up to the data plane service. There's a transport network in between. So that kind of steering is typically out of scope of mobile communication system standards, including 3GPP. And that's why we brought it up here. So that's a basic scenario. Throughout the discussion, next slide, please. We went through architectural aspects and also having in the view more advanced scenarios and use cases. So we asked, so where would it make sense to write down some challenges, ideas, maybe even semantics that apply between control plane functions? And next slide, please. We came up with even more general topics that could be looked at. So architectural aspects, we came up with two main differential architecture aspects, more decentralized, the other one a centralized control plane, not in the mobility control plane, but in the transport control plane. So we want to keep the mobility communication system aspects very, let's say, independent of the solution that we discuss here. That's a big point here. Mid-session and over. So if we want to have data plane to not break, but also to avoid reordering packet, which you have if you switch a path mid-session. So that's a thing to look at, and there is a draft already available for that. UE to UE communication. So if we have really a local kind of breakout of traffic and have UE to UE communication, and UE is our mobile. So also here we need to steer traffic between the mobility anchor points, which may be pretty close to the edge. Cross-domain mobility aspects, end-to-end QoS, functional architecture representation. So also synergies with other standards groups, saying that the discussion we have here, we want to be independent of mobility communication systems. There's a clear customer of that kind of technology where we should interwork with, but we should not interfere with that kind of standardization. So that's the main principle about this. Next one, please. That shows one of the two architectures that we look at, which is more controller-based architecture. As you see here, there may be multiple instances of transport control plane, but important here is the semantic to interwork with the mobility control plane to drive the use cases we have in mind. Also on the data plane, the reordering solutions that we looked at or the challenges, that's all documented in the current graph. Next one, which shows actually a more decentralized or distributed routing plane. And that's another aspect that we look at. Each having pros and cons, but we want to be flexible here. Next slide, please. So through this exercise, we have some lessons learned. By the way, this is all past slides, so nothing new beside the last slide here. So we concluded that the end-to-end problem statement cannot be generalized. So we want to have more a kind of, well, informational draft or best current practices first before we enter solution space, because we think IETF has sufficient amount of technology that may be extended to drive these use cases. So we don't want to come up with something new from scratch, which is not needed. Potential work, also architecture, functional architecture options, semantics between control components, data plane aspects. So the starting point we agreed upon was to have documentation as a draft. And if you go to the next slide, this is the current structure, which can be extended, but we had some pause in that, and sorry for that. So we really want to post the first version, even though it's not complete, but it's 0.0 version. So by end of the month, to give people something to read and comment and feedback, and then to work on more revisions. But the main principle of this documentation is to look at the basic but also advanced use cases. That includes MCS's mobile communication system. So that's a typical scenario that the communication system drives relocation of a user plane anchor, and the rest of the system up to the data plane or up to the data network needs to steer traffic accordingly. We may look at other directions like that the data network drives change in the mobile communication system. We look at ephemeral nodes. So if in between data network and the mobile device, there are nodes that may disappear for whatever reason. Let it be a non-terrestrial network, a satellite, or an energy constrained device that's currently being used but then shut down. So you need to steer traffic accordingly in order to not break the system. Data network relocation, it's another use case we'll look at. Again, that's just a starting point, and that can be extended. We looked at framework and architectural aspects here, so differentiating and clarifying the connect between the mobile communication system's user plane and the data plane, which spans the rest between the user plane function and the data network. And then looking at the two architectures that we just sketched, which is dedicated control plane and a decentralized control plane. And then having a section on the analytics and recommendations that we want to give in the various aspects. So deployment options, pros and cons, packet reordering, and data plane protocols that could be taken here. So that's the first shot. We could even think about semantics, information models between control planes, but that could go into a later version of this document, or maybe even a separate one. All right, that's the status, and looking forward to your comments as soon as the draft is out. Thank you.
Any questions, comments? Yeah.
Thank you for your presentation. I'm Taihei Yamaguchi from Keio University, and it is not directly related to your presentation. In edge computing scenario, Etsy says make federation something like edge computing application deployment, and the deployment deployment standardization is the DMM working group issue or not?
So many aspects of how to tackle these problems are also deployment specific. So we treat it more generics and not saying there's anything like a Mac platform with a Mac application, but we just call it data network. Right? So that may be an edge computing site as you refer to. Federation between them, we don't look at that, right? So if you follow a mobile user's mobility by moving also context from an edge computing site to another one, at the same time relocate your user plane anchor, which is a typical follow me scenario, how far the Etsy Mac platform plays a role here, we don't look into this. We will more look at the routing aspects between the data network and the user plane functions.
Okay, thank you. I got it.
Thank you.
I haven't had a chance to read this yet, but what's
It's not
your
yet out.
what's your opinion of and I guess also a question to the chairs. What's your opinion of where this fits in the charter? Does it fit in as we stand now, or do we need to do a slight bit of rechartering? There's some very vague wording in the charter that allows lots of things to happen. But without seeing the specifics, I don't know if it's going to.
In my opinion, Eric, I think the text somewhat when we crafted the text initially, it does consider all of these things generally at a very high level. So I don't believe we should recharter just for this, but yeah.
Okay. Thank you.
Thank you. But it's a good point. We need to check.
Yeah. Okay. That's it.
Right.
Thank you so much. That we end this meeting. Thank you so much.
Thank you.
Okay. Bye. So it's right on time.
People can check the names in the notes. I didn't get everyone's last name, so.
Okay, that's fine. Okay. Darren, thank you so much. Bye.
Thank you very much. I didn't expect you here. I'm sorry. Thank you very much.
I didn't put last names. If you want your last name in the notes, just go to Darren Kennedy.
Thank you, Satoru-san. That was a good meeting.
Yeah, thank you very much. It's a good meeting. We did.
Yeah?
We did very good.
We did very good, actually. Everything was smooth.
Yeah.
I didn't have any laptop issues.